Okay, so as I promised in my most recent video in the derivation of the sum and product of roots of a quadratic equation, today I'm going to give you examples on how to make use of the sum and product of roots in finding the quadratic equation. And of course, we're going to use also the same formulas in determining the sum of the roots and the product of the roots of a given quadratic equations. So this time, I'm going to give you or provide you examples. There are 7 examples, I suppose, of which there are 3 examples where roots are given, and we are going to find the quadratic equation, and the other 4 are given the equations. We're going to determine the sum and product of the roots. Okay. Okay. So we have here using the sum and product of roots in finding the quadratic equation. So if we recall, the sum of 2 roots can be represented by root 1 plus root 2 or r1 plus r2 equals negative b over a, or the negative of r1 plus r2. And the product of the roots could be represented by root 1 times root 2 is equal to c over a. Our a, b, c here are the numerical coefficients. A is the numerical coefficient of the first term in the quadratic equation. B is the numerical coefficient of the second term in our quadratic equation. And C is our constant term in a given quadratic equation. We are going to use these formulas in finding the equations given the roots. Okay. For example, find the equations whose roots are given. Number 1, root 1 is 3/4 and root 2 is 1/2. Number 2 is root 1 is 5 square root of 2, and r2 is equal to the negative 2 square. R2 or root 2 is negative 7 times square root of 2. And example number 3 is root 1 is equal to 1 plus 2i. And root 2 is equal to 1 minus 2i. Okay? So again, we are going to use these formulas in finding the equations given the roots. Okay? So first, take note that in our discussion last time, okay, we have x squared plus the sum of the roots times x plus the product of the roots equals 0. Okay, or you also have x squared plus the negative of b over a of x plus c over a equals 0. Okay, so we are going to use the two for the two equations, whichever be the most appropriate. Okay, so the first one is r1 is equal to 3/4 and r2 is equal to 1/2. So first is r1 is equal to 3/4 and r2 is equal to 1/2. Okay, so based from the given, okay, we are going to find first the sum and eventually the product. So the sum, r1 plus r2, is equal to 3/4 plus 1/2. Okay, take note that our roots are fractions and these are dissimilar because they have different denominators. First is we have to make these fractions similar by determining the LCD. The LCD is the number that can be divided both by the two denominators. So the LCD is 4 divided by 4 is 1 times 3 is 3. Plus 4 divided by 2 is 2 times 1 is 2. And the sum of the roots would be 5 over 4. Okay, 5 over 4. And the product, R1 times R2, is equal to 3/4. Okay, 3/4 times 1/2. And in multiplying fractions, we just multiply the numerator by numerator and denominator by denominator. So we have the product of the two roots, R1 and R2, is 3 over 8. Okay, so the equation, so given our sum and product of our roots, okay, the equation, the possible equations could be x squared plus the negative of R1 plus R2 of x plus the product of the roots R1 and R2 equals 0. Since our sum is the negative of 5 over 4 of x and the product is 3 over 8 equals 0, okay, we have x squared minus 5x over 4 plus 3 over 8. Okay, so this could be our quadratic equation, but it is more appropriate if we express that in the form of ax squared plus bx plus c equals 0. Okay, we express that in the form of ax squared plus bx plus c equals 0. So what shall we do? We multiply, okay, we multiply the LCD or the LCD, the least common denominator, or we determine the least common denominator of this fraction, so we can express that into the standard form of quadratic equation. So our LCD here is 8. Okay, so we have 8. 8 times x squared is x squared 8, or 8 times x squared is 8x squared. 8 divided by 4 is 2 times 5 is 10 times x is 10x. 8 divided by 8 is 1 times 3 is 3 equals 0. Okay, and we have to get rid of our denominator here. So all we have to do is to multiply the multiplicative inverse of 8, which is 1 over, which is all we have to do is to so notice that there is a denominator here, and we have to eliminate this or get rid of this denominator, so we can express that into the form of ax squared plus bx plus c equals 0. All we have to do is to multiply the multiplicative inverse of 8 here, okay, and which this must be 1 over 8, and we multiply it by 8 to both sides of the equation. So we have cancel, and 8 times 0 is 0. So what is left is x squared minus 10x plus 3 equals 0. So this is our quadratic equation. So we form our quadratic equation as 8x squared minus 10x plus 3. Okay. So number 2 example. Number 2 is R1 is equal to 5 square root of 2, and R2 is negative 7 square root of 2. Okay, so we have the sum, R1 plus R2 is equal to 5 square root of 2 plus the negative of 7 square root of 2, and that is 5 square root of 2 minus 7 square root of 2 equals 5 plus negative 7 is negative 2 square root of 2. These are similar terms. These are similar terms in the radical. Okay, since they have the same radicand and they have the same index. So we just subtract the integral part of these terms. Okay, so the sum of the two roots is negative 2 square root of 2, whereas the product would be 5 square root of 2 times negative 7 square root of 2. So 5 times negative 7 is negative 35. And square root of 2 times square root of 2 is square root of 4. And that is negative 35. Square root of 4 is a perfect square. 4 is a perfect square. So the square root of 4 is 2. So R1 times R2 is equal to negative 35 times 2. And R1 times R2 is equal to negative 70. Okay? So the sum of the roots is negative 2 square root of 2. And the product is negative 70. So again, we are going to form the equation. Okay. So we have x squared plus the negative of R1 plus R2 of x plus the product of R1 and R2 equals 0. And we have, okay, x squared plus the negative of negative 2 square root of 2 of x plus the negative of 70 equals 0. So we just substituted the sum of two roots, which is negative 2 square root of 2, and the product of two roots, which is negative 70, to our R1 plus R2 and R1 times R2 respectively. So we have x squared here. Negative times negative is positive. 2 square root of 2 of x minus 70 equals 0. So this is our form quadratic equation, whose roots are 5 square root of 2 and negative 7 square root of 2. Okay? And number 3, in this example, is R1 is equal to 1 plus 2i, and R2 is equal to 1 minus 2i. So again, our sum, R1 plus R2 is equal to 1 plus 2i. So our I there is our imaginary number. Imaginary number. So we go beyond our real numbers. We go beyond our real numbers. So we include here our imaginary number so that you will be used on how to operate, okay? Or you will be introduced on how to operate imaginary numbers. And then this is our first root, plus the second root is 1 minus 2i, okay? Equals 1 plus 2i. So we get rid of our grouping symbols now. Plus 1 minus 2i equals. So our 2i here has opposite signs. So we can cancel these terms. And then what is left is 1 plus 1, which is equal to 2. So our product, or the sum of our roots, is 2. Okay? Whereas in our product, we have R1 times R2 equals 1 plus 2i and 1 minus 2i. R1 times R2 is, if you notice that our factors here are factors of difference of two squares. Remember? Difference of two squares. So we have 1 here and 1 there, 2i and 2i there, but they have different signs. They have opposite signs. So these are factors of difference of two squares. So that given the factors of two squares, all we have to do is to multiply the first term by the first term. So we have 1 times 1 is 1. Okay. Positive times negative is negative. 2i times 2i is 4 times I squared. Okay. So R1 times R2 is equal to 1 minus 4. The equivalent of our I squared here is equal to negative 1. Okay? The equivalent of I squared is equal to negative 1. That is a rule under imaginary numbers. So we have here negative 1. So we substitute the value of I squared, which is negative 1 here. Therefore, we have R1 times R2 is equal to 1 plus 4, and R1 times R2 is equal to 5. So the product of the roots R1 and R2 is equal to 5. Okay. Now we are ready to find or to form the equation of these two roots. So the equation now would be x squared plus the negative of R1 plus R2 of x plus the product of R1 and R2 equals 0. So we have x squared plus the negative of 2x plus the product of roots, which is 5, equals 0. By simplifying it further, we have x squared minus 2x, okay, plus 5 is equal to 0. So this is our equation that we have formed given our roots, which are 1 plus 2i and 1 minus 2i. Okay, so that's how we make use of the sum and product of roots in finding the equation when in the second degree. Okay, finding the quadratic equation. Okay, next, find the sum and product of roots of each of the following equations. So this is our second part of the examples. We have finding. This time we're going to find the sum and the roots, the sum and the product of the roots given the equations. So find the sum and product of roots given the equation. Okay. Sorry. So number 1 or number 4, we have x squared. So take note, we're going to find the sum and product of roots when we have our equation. So the first equation is x squared minus 3x plus 4 equals 0. So using our formula for the sum, R1 plus R2 equals negative B over A. Okay. Take note that our B is negative 3, our A is 1, and our C is 4. So by substitution, we have negative of negative 3 over 1. 1 is our value for A, and that is positive 3. So negative of the negative 3 over 1 is positive 3. So the sum of the roots of this specific quadratic equation is 3. Whereas the product, okay, C over A is equal to, our value for C here is 4, and our value for A is 1. Therefore, the product of the roots is 4. Okay, so to check whether our sum and product of the roots are correct, then you can have your check or checking activity by using quadratic formula. Okay, and then do the operations for sum and product of the roots. Okay, for number 5, we have x squared minus or plus 4x minus 7 equals 0. Okay, so our R1 plus R2 is equal to negative b over a, which is equal to negative 4 over 1, and the sum is negative 4. Okay, and the product R1 times R2 is equal to c over a, and that is negative 7 over 1 equals negative 7. So our sum is negative 4 and our product is negative 7. Number 6, 3x squared plus 2x plus 1 equals 0. So our R1 plus R2 is equal to negative 2 over 3. Our R1 plus R2 is 2 over 3. R1 times R2 is equal to 1/3. And lastly, we have number 7, 4x squared minus 5x minus 3 equals 0. So we have R1 plus R2 is equal to 5 over 4, and R1 times R2 is equal to negative 3 over 4. So that's how we make use of our sum and product of the roots of a given quadratic equations. So we can make use of these formulas in finding the equation. Okay, and we can make use of these formulas also in finding the sum and product of the roots of a given quadratic equation. So again, please like, please share, and please don't forget to subscribe into my channel so that you will be informed of our succeeding videos. Okay, I hope you have learned something again, and hopefully we will have our trigonometric functions later. Okay, thank you.